All right, this is your first class review for the test that you have coming up either on the 19th for the odd hours or the 20th for the even hours. So we're going to do this to kind of help us prepare. This review helps us with the graphing portion of it. So vertex form, remember, is y equals x minus h squared plus k. The standard form is y equals ax squared plus bx plus c. So these first two, they're in vertex form, and when they're in vertex form, we can read the information directly from the equation. So the vertex is -3, -8. The axis of symmetry is x equals -3. This graph, because it starts with a positive number 2, opens up, so the vertex is the lowest point, so it's a minimum at the y-coordinate. Now, domain and range we haven't done a bunch, so let's go ahead and graph it, and then we'll use the graph to help us identify domain and range. So the vertex is -3, -8. Now, normally for these patterns we use, or for these graphs, we use the pattern where we go over 1, up 1, over 2, up 4. But this time, because of the 2 in front, we have a vertical stretch. So the up gets doubled. So we're going to go over 1 and up 2, and then over 2 and up 4. Or excuse me, normally, and then we'd go over 2 and up 4, but 4 doubled is 8, so we'd go up 8. And there's our graph. The domain is the x values, and it goes left to right, and this graph will keep getting wider, so the domain is -8 to 8. I totally said that wrong. I wrote it right, said it wrong. Is -infinity to infinity. And the domain is the same on all of these. The range, we go from bottom to top, so there's nothing, and then it starts at -8, and there's a bracket because that point is included, and then it continues on to infinity. All right, on our second one, the vertex, opposite of what's in the parentheses, so 5, and then the number at the end, 6. Axis of symmetry is x equals the x-coordinate, which is 5. This graph, because of the -1/2, opens down, so our vertex is the highest point. It's a vertex or a maximum, and it's a maximum at the y-coordinate of 6. We'll graph this one to get more information. So I'm going to start by graphing the vertex, which is 5, 6. Now normally, again, we'd use our pattern, over 1 and up 1, over 2 and up 4. But it's negative, so it's going down, and we have a half, so we don't go down as much. So normally we go over 1 and down 1, but we have to go half of that, so we're going to go over 1 and down, whoa, what happened? Over 1 and down a half. And then normally we go over 2 and down 4, but half of that is 2, so we're going to go over 2 and down 2. And now our graph is wider, because it shrank vertically. All of these have the same domain, -infinity to infinity. And the range, now I do have values down here in the negative, so it starts at -infinity, but stops at 6. And it's a bracket, because 6 is included. All right, for these problems, we need to find the vertex in the in the y-intercept. The vertex is found by taking -b over 2a. That'll give you the x-coordinate. So this is my a, my b, my c. So opposite of b would be -6 over 2 times a, which is 1, which is -3. So this is -3. Now to find the y, I need to plug in -3. So I have -3 squared plus 6 times -3 plus 4. So that's 9 minus 18 plus 4, which would be -9 plus 4, which would be -9. So my vertex is -3, -5. Right here. Now on these, when we graph it, we're going to use the y-intercept. So we're not going to use the pattern, but the pattern does fit, but I want you to use the y-intercept. The y-intercept is when x is 0. So if I plug in a 0 for the x squared, a 0 for that, it's going to cancel out, and all I'm going to be left with is just 4. So the y-intercept is 0, 4. And the last number and the y-intercept are always going to match. So this is 0, 4. And now to graph it, I'm going to graph a vertical line down my vertex because the graph is symmetric on the vertex. And since this point was 3 to the right, I'm going to count point 3 to the left, and then I'm going to connect my 3 points and graph. All right, let's try that one more time. So the vertex, I can find the x-coordinate by taking the opposite of b over 2a. So this is a, b, and c. So the opposite of b would be negative 8 over 2 times a, which is negative 2. So I have negative 8 over negative 4, which is 2. So my vertex is 2 something. Now I need to find the y by plugging it in. So I have negative 2 times 2 squared times 8 times 2 minus 3. So first I have to square the 2, which is 4, and then multiply by the negative 2, so I get negative 8 plus 16 minus 3. So negative 8 plus 16 is 8 minus 3 would be 5. So my vertex is 2, 5. Now I need to find the y-intercept. Remember, the y-intercept is always the number at the end, so it's going to be 0, negative 3. To do my graph, I know that my parabola has to be symmetrical on the line that runs through the vertex. So since this point was 2 to the left, this has to be 2 to the right, and there is my parabola. This last type is what we did on the last quiz, so this should be more familiar to you, or at least more current in your memory. To find the x-intercept, we have to plug in 0 for y, and now we have to factor it. We cannot factor it with a leading coefficient of negative, so we know we have to take out something, but this one I can take out more than a negative 1. I can actually take out a negative x, and negative x squared by negative divided by negative x is positive x. Negative 4x divided by negative x is positive 4. Now I don't have to factor anymore because these are just x's, not x squared. So now I know that negative x equals 0 or x plus 4 equals 0. Well, x can't be negative, so that gives me 0, 0 for this x-intercept. When I solve here, I get negative 4, so this one gives me negative 4, 0. So graph those two. The vertex is going to be halfway in between, so at negative 2. Now we're going to plug in negative 2 to figure out what our y would be. So in this, first you have to square the negative 2, which is positive 4, and then add the negative. So I get negative 4 plus 8, which is 4. So my point is negative 2, 4. And then it opens down. There's one positive interval in between the two numbers, smaller number on the left, so it's negative 4 is less than x, which is less than 0. There are two negative intervals here and here. It's always less than the number on the left, less in L, and left all start with L, and it's greater than the number on the right. So x is less than negative 4, and x is greater than 0. One last one. To find the y-intercept, I said that completely wrong. To find the x-intercept, you're going to plug in 0 for y, and now you're going to factor it. This is a trinomial with a leading coefficient of 1, so I'm going to go straight to my two parentheses. The two numbers that multiply to negative 3 and add to 2 would be positive 3 and negative 1. This gives me negative 3, 0, and this one gives me 1, 0. Halfway in between would be negative 1, and now I need to plug in the negative 1. So y equals negative 1 squared plus 2 times negative 1 minus 3. This is 1 minus 2 minus 3. 1 minus 5 is negative 4. So this is negative 1, negative 4. Connect my points and graph. This one has two negative intervals, one here and one here. The one on the left, it's always less than the one on the left, so it's less than negative 3. So x is less than negative 3, and x is greater than the one on the right, which is 1. The negative interval, there's just one of them. It's in between the two things, so negative 3 is less than x, which is less than 1. We'll do more review in the next class.